Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.14. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.14. Find the value of voltage V0 in given below figure using mesh analysis. This is the circuit diagram of given problem. Inside this network, we have to find the value of voltage across this 6 kilo ohm resistance labeled as V0 using mesh analysis technique. So without wasting time, let's proceed towards the solution. We know that in order to apply mesh analysis on a network, we have to follow some steps. The first step includes finding out the maximum number of meshes that can be formed in the network. We can use this generic equation to find number of meshes in any network. In this network, there are 10 number of branches and 8 number of nodes. So maximum number of 3 meshes can be formed in this network. Because number of meshes is 3, so there will be 3 mesh current equations for this network. These 3 meshes will be formed using these paths in the network. First mesh will be formed using this path. Second mesh will use this path. And third mesh will use this path. In second step, we have to assume currents along with their directions in these meshes. So I am assuming current I1 is flowing through this mesh. Current I2 is flowing through this mesh and current I3 is flowing through this mesh, and all of these currents are flowing in clockwise direction. According to the direction of current, polarity notation across resistive elements is marked. Now we will start writing KVL equations for these 3 meshes one by one. We will start from this mesh. Current entering terminal is positive, so voltage across this 4 kilo ohm resistance will be taken with positive sign. Next, current entering terminal is positive, so voltage across this 3 kilo ohm resistance will be taken with positive sign. Next, voltage of this voltage source will be taken with positive sign because current entering terminal is positive. This voltage source value will be taken with negative sign because current is entering from negative terminal, minus 10 volt. Next, current entering terminal is positive, so voltage across this 2 kilo ohm resistance will be taken with positive sign. And at the end, current entering terminal is positive, so voltage across 3 kilo ohm resistance will be taken with positive sign. Now we have to replace all these voltages with their respective equations. Voltage across 4 kilo ohm resistance is the product of current through it, that is the difference of current I1 and I2, because these two currents are passing through 4 kilo ohm resistance and both are opposite to each other. Here we have taken the polarity of voltage across 4 kilo ohm resistance according to the direction of current I1, which is indicating that the magnitude of current I1 is larger than I2. That's why we have subtracted current I2 from I1. So voltage across 4 kilo ohm resistance will be the product of I1 minus I2 and 4 kilo ohm. Similarly, voltage across this 3 kilo ohm resistance will be equal to the product of current I1 minus I3 because current I1 and I3 is flowing through this resistance and both are opposite in direction to each other. So voltage value across this 3 kilo ohm resistance will become I1 minus I3 multiplied by 3 kilo ohm. Voltage across 2 kilo ohm resistance will be equal to the product of current I1 and 2 kilo ohm because only I1 current is flowing through this 2 kilo ohm resistance. Similarly, voltage across this 3 kilo ohm resistance will also be equal to the product of current I1 and 3 kilo ohm. Now open these brackets and take the product of constant values with variables inside the brackets. The equation will become 4k I1 minus 4k I2 plus 3k I1 minus 3k I3 minus 2 volt and plus 2k I1 plus 3k I1. Now add values that have same variable together. Their sum will be equal to 12k I1 minus 4k I2 minus 3k I3, and place this constant on the other hand side of equal to separate it from variables. This equation includes three variables. We cannot further solve this equation, so we will leave it for now and label it as equation A. It is the first mesh current equation of this network. Move towards the second mesh. Now we will apply Kirchoff's voltage law inside this second mesh. Start from here. Current entering terminal is negative, so 12 volt will be taken with negative sign. Next, current entering terminal is positive, so voltage across this 6 kilo ohm resistance will be taken with positive sign. Next, current entering terminal is positive, so voltage across 4 kilo ohm resistance will be taken with positive sign. And at the end, current entering terminal is positive, so voltage across 4 kilo ohm resistance will also be taken with positive sign. Now replace these voltages with their respective equations. Voltage across 6 kilo ohm resistance will be equal to the product of 6 kilo ohm and current through it, that is the difference of current I2 and I3, because these two currents are using common path and both are opposite in direction to each other. Here, because we are in second mesh, that's why current I3 will be subtracted from I2. So I2 minus I3 multiplied by 6 kilo ohm will be equal to voltage across this 6 kilo ohm resistance. Similarly, voltage across this 4 kilo ohm resistance will be equal to the product of these two currents difference and the value of resistance. But this time current I2 minus I1 will be taken because we are in mesh 2 and this current is considered as higher current than current I1. That's why we have taken the difference of these two currents as I2 minus I1. And at the end, voltage across 4 kilo ohm resistance will be equal to current I2 multiplied by 4 kilo ohm, because only current I2 is flowing through this resistance. Now open these brackets. The equation will become minus 12 volt plus 6k I2 minus 6k I3 plus 4k I2 minus 4k I1 plus 4k I2. Now add values having same variables together and arrange the equation. Place this constant on the other hand side of equal. The equation will become minus 4k I1 plus 14k I2 minus 6k I3 equal to 12 volt. Again, this equation includes three variables and we cannot further solve this equation, so we will leave it for now and label this as equation B. It is the second mesh current equation of this network. Move towards the last mesh. Apply KVL inside this mesh. Start from here. Current entering terminal is positive, so voltage across 6 kilo ohm resistance will be taken with positive sign. Next, voltage across this 6 kilo ohm resistance will also be taken with positive sign. Next, minus 8 volt will be taken because current is entering from negative terminal, and at the end current is entering from positive terminal, so voltage across this 3 kilo ohm resistance will be taken with positive sign. Now replace these voltages with their equations. Voltage across 6 kilo ohm resistance will be equal to the difference of these two currents multiply the value of resistance, but this time current I3 minus I2 will be taken because we are in mesh 3 and we are considering current I3 through this resistance is larger than current I2. Here voltage across this 6 kilo ohm resistance will be equal to the product of current I3 and 6 kilo ohm. Similarly, voltage across this 3 kilo ohm resistance will be equal to current I3 minus I1 multiplied by the value of resistance 3 kilo ohm. Now open these brackets and solve this equation. The equation will become 6k I3 minus 6k I2 plus 6k I3 minus 8 volt plus 3k I3 minus 3k I1. Arrange this equation and add values that include same variable together and place this constant on the other hand side of equal. The equation will become minus 3k I1 minus 6k I2 plus 15k I3 equal to 8 volt. And label this equation as equation C. It is the third mesh current equation of this network. Up to this point, we have calculated three mesh current equations of this network. Now we will try to solve these equations together in order to calculate the value of current I3. We are interested to calculate the value of current I3 because using this current we can calculate voltage across this 6 kilo ohm resistance that are labeled as V0, and in this scenario it is asked to calculate the value of V0. So first of all we will try to solve this equation in order to get the value of current I3. For that purpose we will take equation A as it is, multiply equation B with 3 and add that resulting equation into A. Product of 3 and minus 4k I1 will become minus 12k I1. Product of 3 and 14k I2 will become 42k I2. Similarly, product of 3 and 6k I3 will become minus 18k I3, and on the other hand side of equal, product of 12 volt and 3 will become 36 volt. Now add these equations together. Plus 12k I1 and minus 12k I1 will cancel out with each other. Subtract 4k I2 from 42k I2, it will become 38k I2. Similarly, sum of 3k I3 and 18k I3 will become minus 21k I3, and on the other hand side of equal, sum of 36 volt and 2 volt will become 38 volt. We will label this equation as equation D, and this equation includes only two variables I2 and I3. Now again we will take equation A as it is. Equation C will be multiplied with 4 and the resulting equation will be added with this equation A. Product of 4 and minus 3k I1 will become minus 12k I1. 4 multiplied by minus 6k I2 will become minus 24k I2. 15k I3 will be multiplied with 4, it will become plus 60k I3. And on the other hand side of equal, 4 multiplied with 8 volt will become 32 volt. Now add these equations together. Plus 12k I1 and minus 12k I1 will cancel out with each other. Here sum of minus 24k I2 and minus 4k I2 will become minus 28k I2. Subtract 3k I3 from 60k I3, it will become 57k I3. And on the other hand side of equal, sum of 32 volt and 2 volt will become 34 volt, and label this equation as equation E. Now in order to calculate the value of current I3, we will multiply this equation with 28 and this equation with 38 and add that resulting equations together to find the value of current I3. So first of all, this equation D will be multiplied with 28. The equation will become 1064k I2 minus 588k I3 equal to 1064 volt. Now multiply this equation E with 38. The equation will become minus 1064k I2 plus 2166k I3 equal to 1292 volt. Now add these resulting equations together. 1064k I2 minus 1064k I2 will cancel out with each other. Subtract 588k I3 from 2166k I3, it will become 1578k I3. And on the other hand side of equal, these two values will be added together. Their sum will be equal to 2356 volt. Now in order to get the value of current I3, divide on both sides with 1578k. Value of current I3 will become 1.49 milliampere. And after calculating the value of current I3, we are able to calculate voltage across this 6 kilo ohm resistance using Ohm's law. Voltage V0 across this 6 kilo ohm resistance will be equal to the product of current through it, that is I3, and the value of resistance 6 kilo ohm. Replace I3 with its value. So the product of 1.49 milliampere and 6 kilo ohm will become 8.95 volt. So the value of voltage V0 inside this network is 8.95 volt. So this was chapter 3 learning assessment E3.14. Thank you. See you again in next video.